Let's see some more practice problems for how to represent negative numbers in binary. So let's do both 4-bit and 8-bit conventions of we'll do sign and magnitude convention. We'll do ones complement and twos complement. Okay, so let's say, let's just represent something straightforward like -6 in binary under the sign and magnitude convention. So the first thing we want to do is we want to find what 6 in binary is. So we're going to convert the magnitude of this number, not the sign. So convert 6 to binary, and that's going to be 1, 1, 0. Now we only need 3 bits in order to count up to 6. But one of the things about converting numbers to negative in binary is that we have to make sure that we specify the size of our binary string first. So if we're going to do 4-bit and 8-bit, we want to write this as a 4-bit and an 8-bit number. So even though we only need 3 bits, the 4-bit representation of this is going to be 0, 1, 1, 0. Okay, so I fill all 4 bits. I don't actually need this 0 here, but I'm going to go ahead and put a 0 as like a placeholder in the most significant bit position. In 8-bit representation, this is going to be all these first 4 bits will be 0, and then we'll have our 0, 1, 1, 0. Okay, so this is 6 in 4-bit binary, and this is 6 in 8-bit binary. And that's the first thing that we want to declare. Now the second thing we're going to do to represent this as a negative number in sign and magnitude form is we want to designate the most significant bit. So that is the leftmost bit. If it's 0, that is going to be a positive number. If it's a 1, that's a negative number. All right, so we have the magnitude 6. Now in order to designate that this is a -6, we're just going to change this most significant bit to a 1. So in our 4-bit representation, the most significant bit is this one, so we're going to change to a 1. So that's going to be 1, 1, 1, 0. Then in our 8-bit representation, 0, 0, 0, 0, 0, 1, 1, 0, this is our most significant bit, so we're going to change this to a 1. So that's going to give us 1, 0, 0, 0, 0, 1, 1, 0. Okay, so this is straightforward using sign and magnitude. But as we talked about before, this does have some limitations. That limitations are kind of freed up by using ones complement instead. So let's convert that same -6 to a negative binary number under the ones complement convention. So this will be example 2. Represent -6 with ones complement. Okay, so for ones complement, just like before, we have to write +6 with both 4-bit and 8-bit representations. So 4-bit again will be 0, 1, 1, 0. 8-bit will be 0, 0, 0, 0, 0, 1, 1, 0. And then what we're going to do is we're going to just invert all the bits. Okay, that's the definition of ones complement. So 1's complement of the 4-bit representation is going to be 1001. 1's complement of the 8-bit representation is going to be 11110110. Okay, so this is now 6 in 4-bit 1's complement and 8-bit 1's complement. And as you can see, if we compare this to our sign and magnitude form, these are definitely different. So when we're solving problems, it's going to be articulated at the beginning, what is our negative number convention, and how many bits are we dealing with? Because if we declare that we're doing 3-bit 1's complement, 4-bit 1's complement, or 8-bit 1's complement, our results are going to be different. Okay, great. So let's see the last example. Let's do 2's complement. So we'll represent -6 with 2's complement convention. All right, so the first thing we want to do, just like we did before, is write out the 4-bit representation of 6, 0, 1, 1, 0, and the 8-bit representation of 6 is 0, 0, 0, 0, 0, 1, 1, 0. And then the next thing we want to do is we want to actually do 1's complement on this number, because the definition of 2's complement is you take the magnitude, you do 1's complement, you add 1 to the least significant bit. Okay, so our second step is to do 1's complement. We did that already. So 1's complement of our number is, our 4-bit number is 1001. And, excuse me, in 1's complement of our 8-bit number is 11111001. Then this third step is we just add 1 to the least significant bit. So in our 4-bit representation, that will be 1001 plus 1, which gives us 1 plus 1 is 0, carry the 1. 1 plus 0 is 1, 0 and 1. And then in our 8-bit representation, that is 1111 1001. We're going to add 1 to our least significant bit. So this gives us 1 plus 1 is 0, carry the 1, 1, 0, 1, 1, 1, 1, 1. Okay, great. So that means that under 2's complement convention, our 4-bit -6 is this, and in 8 bits, our -6 is this. So let me know if you have any questions about doing a number, changing a negative decimal number into a negative binary number using these 3 conventions.